All right, last problem, last video of this section. So, example number 5. Find the volume of the largest rectangular box with edges parallel to the axes that can be inscribed in the ellipsoid 9x squared plus 36y squared plus 4z squared equals 36. This is a long problem. First of all, we have to decipher what all this means. Okay, so we want to maximize volume. So let's go ahead and at least write that part down. Volume equals, x, y, z. But I'm going to put a big question mark next to that because it's not necessarily going to be the case with all this that's going on here. So let's take a look at this. We want to maximize the volume, largest possible rectangular box with edges parallel to the axes that can be inscribed in this ellipsoid. So, you get some kind of an ellipsoid, whatever it looks like, and I'm going to actually show you a pretty good picture of this. And then we want to take a large rectangular box and figure out what the largest rectangular box is that can be inscribed. Means that all the corners need to touch this ellipsoid within the ellipsoid. None of the pieces can go on the outside. So let me tell you, take a look at this. That's not it. Here we go. So it looks something like this, which is pretty cool. So here's your ellipsoid, and that's is actually a sketch of the ellipsoid that we have, and then this is a rectangular box. As you can see, all these different corners here touching the ellipsoid, and the box is completely inscribed. So one of the things I want you to notice is when we start to define the sides of this box, so your length, your width, your height, and so on, what you should be able to see is this piece right here, this long piece that's going across this way, is on the x-axis. But what happens is this piece goes out in a distance of x. This piece goes out in the negative x direction, but it's still a distance of x. So this is one of those cases where the length is not x. The length here is actually going to be 2x because it's this x distance plus this x distance right here. So the entire distance across is 2x. Likewise, the y direction, which is this one, so it's going to be this piece right here, goes out so much space in the y direction, so that'll be a distance of y, but then it also goes this direction in the y direction. So it goes out this way, y, that way, y, so it's actually a distance of 2y, and then likewise the z is the same way. From here to here is z, but from here to here is negative z, but it's actually a total distance of z here, so it's 2z's. So when we go back, what we have to take into account is that the volume is actually going to be, well, the length of the in the x direction is 2x, the length in the y direction is 2y, and the length in the z direction is 2z. So our volume formula is actually 8x, y, z, multiplying all the 2's together. So if you kind of think about it, the way I showed it there in the three-dimensional box there, this is what you're going to get. So the volume is 8xyz. Well, we do have this formula right here, which we're going to have to do some manipulation for, because this is our secondary equation. This is what we're going to be able to eliminate one of these variables with. And again, I'll still go ahead and solve for z like normal. But let's go ahead and put this ellipsoid into a more standard form. So let's divide everything by 36, which will get our 1 on the right-hand side here. So let's see, dividing everything by 36, 9 over 36 is going to give me a 4 on the bottom. So we'll get x squared over 4. Dividing this one by 36, we just get y squared over 1. You don't really have to write the over 1, but I will in this case. And then this one, you're going to get z squared over 9 equals 1. And again, remember that this is going to be your standard equation of the ellipsoid. All right, so in order to solve this for z, I didn't need to do all that, by the way, to solve this for z. Just wanted to put this into its standard equation so that you could see back on this drawing, in the z direction, we had the ellipsoid went out um, 3 and 3, I believe it was. Yeah. And the y direction, it was 1 and 1. So out this direction, 1 unit that way, 1 unit that way. and in the x direction it was 2 and 2. I'm not going to go back to the picture to show that, but you get the idea. So okay, let's go ahead and solve this for z. So that shouldn't be too difficult. We're going to subtract 9x squared and 36y squared from the right. So we get 4z squared equals 36 minus 9x squared minus 36y squared. Divide both sides by 4. We're going to get that z squared is 9 minus 9/4 x squared minus 9y squared. That does not really look like a 4 down there. And then z is going to be the square root of all that. 9 minus 9/4 x squared minus 9y squared. And we can, of course, put the plus or minus, but we're really only talking about distance, so we really want this thing to be positive because z in this case is going to be a distance. So what we can do, however, is I see a 9 in every one of these things. We can factor the 9 out and then take that out to the front of the square root as a 3. So we can write factoring that 9 out of everything and taking the square root of it as 3 square root of 1 minus, what is that, 1/4 x squared minus y squared. So this is our equation for z. So we're going to use this to plug into, this one right here, because this is not actually our equation, this one is. So we're going to go ahead and put the volume as 8x y, and then this is our z, so we've got 3 square root of 1 minus 1/4 x squared minus y squared. Of course, the 3 times the 8 can become 24. 24 x y square root 1 minus 1/4 x squared minus y squared. So we've gone ahead and figured out what we needed to max or minimize. We reduced it down to 2 variables. Now we can start taking partials. So let's take the partial of the volume with respect to x. So it looks like we're going to have a product rule here because it definitely have um, an x in this and then an x in here, and within that product we're going to have somewhat of a chain rule. So excuse me. So let's go ahead and take the partial with respect to x. So the partial of the derivative of this piece right here is going to be 24y times the second piece plus the derivative of this right here, which is going to be 1/2 all of that stuff to the negative 1/2, which really just kind of puts that root on the bottom. I'm not going to fill all that in right now. Um, I will later if I need to. Times the derivative of what's on the inside with respect to x. Well, that part 0, that part 0. So this one is going to give us, what is that, negative 1/2 x. And all of that is just the derivative of this piece times the first piece, which is 24xy. All right, so let's go ahead. Oh, we got to set that equal to 0. All right, we are going to have to solve this for one variable or another. So let's just start simplifying first, and we'll figure it out. So we're going to get 24 square root 1 minus 1/4 x squared minus y squared. Probably should go ahead and fill that in, but I'll do that in the second step here. Let's see. So this is going to be a negative 1/4 times 24 is going to give me a 6. Negative 6, excuse me. X squared y, I think. Does that look right? Yeah, x squared y over square root 1 minus 1/4 x squared minus y squared equals 0. Alright, so let's see, if we add all this to the right, oops, squared, equals 6x squared y over square root 1 minus 1/4 x squared minus y squared. So if I multiply the square root on both sides, this square root right here is going to go away. So I'm going to end up with, let's see, that's 24. Multiplying these two square roots together is just going to give me 1 minus 1/4 x squared minus y squared equals 6x squared y. Alright, so let's see, what can we do now? Can divide a 6 out of both sides. That'll be a 6. Divide a 6 out of here is going to give me 4 times this whole parentheses equals x squared y. Let's go ahead and distribute that 4. So we're going to get 4 minus x squared minus 4y squared equals x squared y. Alright, so I seem to have lost something here. Something's not working out right. What did I lose? Ah, I see what it is. This 24y. I lost my y. I knew something wasn't working out right. There's a y there, which actually means this y can cancel with this y. So that y is actually not even there anymore. Alright, there we go. That makes more sense. So now if I add the x squared to both sides, we'll get 4 minus 4y squared equals 2x squared. Divide both sides by 2, and I get 2 minus 2y squared equals x squared. We'll kind of leave it right there. We won't necessarily solve that for x right now, but we'll leave that. Alright, so let's take the partial of y. Actually, I'm just going to go to my next page. That's why I left it here. So let's see, Vy. Let's see, going back to this page. So partial with respect to y, once again, it's going to be a product rule using this, so it's going to be 24x. So yeah, derivative of the first is 24x times the second, which was the square root of 1 minus 1/4 x squared minus y squared, if I'm not mistaken, plus the derivative of this, which is going to be 1/2 over the whole square root again. I'll write it in this time. And then the derivative of the inside of this is going to be, what is it, negative 2y times the first, which was 24xy. And we have to set that equal to 0. Excuse me, and then we'll do some substitution with the x squared from the previous page. So let's see, let's simplify this. This is going to just be negative y times all this is going to be 24xy squared. So we're going to have 24x square root 1 minus 1/4 x squared minus y squared. And then this is going to be, what did I say, minus y, so it's going to be minus 24xy squared over square root equals 0. So once again, we'll add this to the right. And then once we do that, multiply both sides by that square root. We probably could have done that in one step, but go ahead and write it out. So let's make that a better equal sign. That's horrible. Um, so we're going to go ahead and multiply both sides of this by the square root, and we'll get 24x times this square root, which is going to be 1 minus 1/4 x squared minus y squared. Going to get tired of writing that. Equals 24 x y squared. And then it should be pretty obvious. We can divide out the 24. We can divide out the x. So now we're down to 1 minus 1/4 x squared minus y squared equals y squared. All right, let's add the y squared to both sides, and we're going to go ahead and replace the x squared at this point. So, come on, right. 1 minus 1/4. Now, x squared on the other page that we had solved for was 2 minus 2y. And remember that that was x squared. We didn't actually solve for x. It was already x squared. So we're going to replace the x squared with 2 minus 2y equals 2y squared. So we actually do end up with all y's in this case. Looks like we're going to end up with a quadratic. So let's see what happens here. 1 minus 1/2, distributing the negative 1/4, plus 1/2 y, and so y equals 2y squared. It is going to be quadratic, but let's go ahead and multiply everything through by 2 so we can get rid of those fractions. So we'll get 2 minus 1 plus y equals 4y squared, multiplying this entire row by 2. So then we're going to get 0 equals 4y squared minus y, subtracting y, and that's 1, so we'll subtract 1. And once again, something doesn't seem to be working out, because I don't think we should have gotten this quadratic. This should have been a y squared. Let me go back to the other page and see if I made a mistake here in my substitution somewhere. Ah, I did. It's 2 minus 2y squared. So when I said I remembered, I didn't remember. This should be a 2y squared right there. Okay, makes a big difference. So that's a squared, and that's a squared. So then when I add this over, it's actually going to be just, I'm sorry, subtract it over, it's going to be a 3y squared, not a 4y squared, and there is no more y term. So let's fix that. 3y squared, that's 1 subtracting 1. Okay, now we can solve for y, adding 1 and dividing by 3. 1/3 equals y squared, taking the square root. Y equals the square root of 1/3. Taking the square root of top and bottom, we get 1 over root 3. And we don't need, again, we don't need to worry about the negative of this, because that would be a negative distance for y, and that makes no sense. So we do have y. It took a long time to get there. Now we can go back and find x. So x squared, let's see, this was x squared right here. That much I do remember now, was 2 minus 2y squared, which is 1 over root 3 squared, because that's y. So let's see what we get now for x. X squared is going to be 2 minus, squaring this is 1/3, so that's 2 minus 2/3. And 2 in terms of thirds is going to be 6/3, so 6/3 minus 2/3 is 4/3. So that means x, taking the square root, square root of the top is 2, square root of the bottom is root 3, is 2 over root 3. And then we can use all of those to be able to find z. And this one I'm going to have to go back and look at. Z was this big square root right here, or we can use this simplified when it doesn't really matter. So z is 3 times the square root that we were using the whole time. So z is 3 times square root of 1 minus 1/4. It was x squared, so 2 over root 3 squared minus y squared, which was 1 over root 3 squared. So let's see what we get here. So that's going to be 3 times 1 minus, this thing squared is 4/3. 4/3 times a fourth. Let's see, 4/3 times a fourth is 4 over 12, 1/3. Minus, squaring 1 over the square root of 3 is 1/3. So we get 3 times, let's see, 1 minus a third minus a third is a third. And that looks like we're going to get, um, again, something doesn't seem right there, because that would be 3 over root 3. That doesn't seem right. Something's wrong. Actually, no, it isn't. Let's, oh, come on, right. 3 over root 3. Rationalizing that, multiplying by root 3 over root 3 is, what is that, 3 root 3 over 3, getting, okay, that's right. It is root 3. Yeah, just wasn't thinking of the right form. Alright, so there's z. So we have x, we have y, and we have z. But we do have to make sure we answer the question, which was, what's the volume of the largest rectangular box? So the volume, remember, was 8 times xyz. So the volume, after all this, is 8 times x, 2 over root 3, times y, 1 over root 3, times z, which is root 3. Those cancel out. You're going to get 16 over root 3, whatever the units are cubed. I don't think it gave us units. Nope, no units on that one. So there we have it, 16 over root 3 is your volume. Long problem. That one took about 23 minutes, so there you go.